we have a parabola whose focus and the equation of directrix is given, right? If you look carefully, the focus is given at 2 comma 5 and the equation of directrix is given as y is equal to 3, or you can say that it is nothing but y minus 3 is equal to 0. Correct? We have to determine the equation of that parabola. Okay, now let us also have a look at the options. So these are the set of options in front of you. Quickly moving to the solution part, let me retain the information which is important. So again, the focus is at 2 comma 5 and the equation of directrix is y minus 3 is equal to 0. We have to determine the equation of this parabola. So in coordinate geometry, doesn't matter which question are you attempting for. It can be from ellipse, it can be from hyperbola, it can be from parabola. The moment you will start attempting those questions by drawing a rough diagram is the moment when you are going to get excel in it. So let me quickly draw a rough figure for this particular case. Okay, so I have marked the focus by point S and I have mentioned its coordinate as 2 comma 5. This line L is my directrix. The equation of the directrix is y minus 3 is equal to 0. And I have assumed a variable point P having a variable set of coordinates x comma y. This point P is going to move in such a way so that the curve generated is going to be of a parabola. Now you all have remembered a very important property about the parabola. What is it? Can you all quickly recall? Yeah. So parabola is a locus of all such points which moves in a way. I repeat myself, parabola is a locus of all such points which moves in a way so that its distance from a fixed point is equal to its distance from a fixed line. The fixed point is nothing but the focus and the fixed line is nothing but the directrix. Correct? That means this point P is going to move in somewhat this path, right? And the curve generated is going to be of a parabola. Now, according to the property, the distance of P from S is always going to be equal to the distance of P from M. So, we have PS is equal to PM. Now, suppose PS is equal to PM, and if I square both the sides, what I'll get? I'll get PS square is equal to PM square. The distance PS can be calculated by the distance formula, right? So PS square is going to be equal to, okay, I'm writing the value of PS square. It's going to be equal to x minus 2 whole square plus y minus 5 whole square is equal to, now I have to write the value of PM, and more over that I have to write the value of PM square. How can you find the distance PM? So we have been given with the equation of a line L, and we already know a formula where we can calculate the distance of a point from a line. Remember, there was a line having the general equation as ax plus by plus c is equal to 0, and there was some variable point line somewhere having the coordinates x1 comma y1. Then in that case, the distance of that point from the line is going to be equal to mod ax1 plus by1 plus c upon root over a square plus b square. Correct? So our given line is y minus 3 is equal to 0. I am just going to write, or you can say I am going to just rewrite this equation in the form of general equation of a line, so that we can conveniently find the values of the constant or the set of constants a, b and c. So y minus 3 is equal to 0 can be written as 0 times x, right? There is no term containing x, plus 1 times y minus 3 is equal to 0. Now it is pretty clear that a is 0, b is 1 and c is minus 3. Correct? So PM is nothing but mod of ax1. So a is 0, the point x1 is itself x, so 0 into x gets vanished out. B is 1, the point y1 is itself y, so I'll get y. C is the value of constant as minus 3 upon root over a square plus b square. A is 0, so let me write it for you. 0 square plus b is 1, so it will become 1 square. And if you remember, we have to write the value of pm square. So I'll be squaring the whole expression, correct? Now what we'll have to do, we'll just have to simplify it and we'll get the equation of the parabola. Okay, so I can further rewrite it as x minus 2 whole square plus y minus 5 whole square mod y minus 3 square is going to be equal to y minus 3 square upon, there is root over 1. Root over 1 is 1 and the square of 1 is also 1. So I'm going to write nothing in the denominator. It's self understood that there is a 1 lying in the denominator. Okay. On simplifying further, x minus 2 whole square can be written as x square plus 4 minus 4x plus y minus 5 whole square can be written as y square plus 25 minus 10y is equal to y minus 3 whole square can be written as y square plus 9 minus 6y. Okay. Now, again on rearranging the terms, let me first write the term of x square. So we have a single term containing x square. Now I'm going to write the term of y square. So on the left hand side also we have y square, on the right hand side also we have y square. It's going to get cancelled out. Okay. Now let us look for the term containing xy. There is no term containing xy. Now I'll be writing the term containing x. Okay. So I just have minus of 4x here. Cool. What I'll do after that, I'll write the terms containing y. Okay. So I have minus 10y over here and minus 6y over here. This minus 6y when moved to the left hand side of the equation, it will become plus 6y. Now minus 10y plus 6y is going to be equal to minus 4y. Okay. Now what is left is just the set of constants. So 25 plus 4 becomes 29 and there is a 9 on the right hand side which will get subtracted from 29. So what I'll get plus 20. So finally I have x square minus 4x minus 4y plus 20 is equal to 0. And this is what our required equation of parabola is going to be. So the final equation is x square minus 4x minus 4y plus 20 is equal to 0. Cool? Easy. Let us go and have a look at the options part. Yeah, option C is the absolutely correct option. So now in this question, we have to find the equation of a parabola, okay, whose focus lies at the intersection point of the lines x plus y is equal to 3 and x minus y is equal to 1. And the equation of directrix is also given to us, which is x minus y plus 5 is equal to 0. Okay. So if we try to conclude this entire question, so we can say that first of all, there are two lines, or more precisely, there are two intersecting lines. Okay. The equation of both the lines are given. One is x plus y is equal to 3 and the other one is x minus y is equal to 1. Now, at the point where these two lines are intersecting lies the focus of the parabola. Okay. And there is one more line. The equation of this line is x minus y plus 5 is equal to 0. This is the directrix of the parabola. So we know the equation of directrix, and yes, we will have to know the coordinates of the focus. How we are going to determine the coordinates of the focus? Any clue? Any hint? I can't hear you. Yes, as simple as that. We just have to solve both the equation of the lines. That's all. That's how we are going to get the coordinates of the focus. Correct? So we will be solving these both the equation of the line by using the system of linear equation in two variables. From there, we'll be getting the coordinates of the focus. Once the coordinate of the focus is known, The equation of directrix is already given to us. It is no bigger deal to determine the equation of the parabola. Correct? Before moving to the solution part, let us have a look at the options also. Okay, so these are the lengthy, dangerous options given in front of you. Okay, see, we have to be very precise in terms of calculation. Okay, now moving to the solution part, let us first retain the information which was there in the question. So it was given that the focus of the parabola was lying at the point of intersection of these two lines, and the equation of directrix was also given. We have already discussed this thing that in order to find the focus, we have to solve this equation of line. See what is given here, x plus y is equal to 3 and x minus y is equal to 1. The moment I'll add both this equation, what I'll get x plus y plus x minus y is equal to 3 plus 1, which is 4, plus y and minus 5 will get cancelled out. I'll get 2x is equal to 4, right? Which gives me the value of x as 2. Correct? You put this value of x as 2 in any of the equations. Say if I'm putting it in the second one, what I'll get 2 minus y is equal to 1, right? 2 minus y is equal to 1. This will give me the value of y as 1. Correct? So on solving both this equation, I am getting the value of x as 2 and the value of y as 1. So that means 2 comma 1 is nothing but the focus of the required parabola. Correct? Again, I'm going to draw a rough diagram. Okay, so this is how the rough diagram is going to look. See, we have the focus lying at 2 comma 1. The equation of directrix is given to us as x minus y plus 5 is equal to 0. I have assumed a random variable point having the variable set of coordinates x comma y, which is going to move in the parabola. Doesn't matter, it lies anywhere. The distance of point P from the focus and the distance of this point P, or the perpendicular distance of this point P from the directrix, is always going to be equal. Correct? So that means PS is going to be equal to PM. PS can be calculated by using a distance formula. Tell me the value of PS. So it is going to be root over x minus 2 whole square plus y minus 1 whole square is equal to PM. You remember the formula of a perpendicular distance of a point from a line? It's mod ax1 plus by1 plus c root over a square plus b square upon root over a square plus b square. Correct? Okay. So I am going to write the distance PM. Okay. The given equation of directrix is x minus y plus 5 is equal to 0, and the variable points is x comma y. So I have to write the distance PM. So A is 1, x1 is itself x. So what I'll get x, then by1 will become minus of y. Correct? And C is plus 5, so it will remain plus 5 upon root over a square plus b square. So I'll get 1 square plus of minus 1 square, correct? Because a is 1 and b is minus 1. Now, there is a root lying onto the left hand side. We have to remove that root. Okay. What I'm going to do, I'm going to square both the sides of the equation and I'll get this. Have a look. I'm not in a mood to rush. Just have a look. Take your time. Correct? Everything is smooth till now? Okay. Now moving further, I'm going to retain this step and I'm going to simplify it more. Okay. What I'll get, x minus 2 whole square becomes x square plus 4 minus 4x plus y minus 1 whole square will become y square plus 1 minus 2y is equal to, onto the right hand side, there is x minus y plus 5 whole square in the numerator and root 2 in the denominator. Correct? Are you all able to look root 2 in the denominator? Okay. Now, let me first expand the numerator part. The numerator part says x minus y plus 5 whole square. What I can write? I can write a minus b plus c whole square. What I can write is x square plus y square plus 5 square is 25 minus 2xy, correct, minus 10y, okay, plus 10x. This is what x minus y plus 5 whole square is. In the denominator there was root 2 and the square of root 2 is 2. This 2 in the denominator will go on to the left hand side and will get cross multiplied. What further I'll get is 2x square plus 8 minus 8x plus 2y square plus 2 minus 4y is equal to x square plus y square plus 25 minus 2xy minus 10y plus 10x. Now I'm going to once again rearrange all these terms. First of all, I'm going to write a term of x square. So we have 2x square on the right and we have x square on the left. So finally we are going to get x square, correct? Now I'm going to write the term of y square. So again we have 2y square on the left and y square on the right, which will finally become y square, correct? Now I'm going to write the term containing xy. So on to the right we have minus 2xy, which when will come onto the left hand side will become 2xy, correct? Now I'm going to write the term containing x. So we have minus 8x here, okay, and yes, we have 10x onto the right hand side. So when it will come onto the left hand side, it will become minus 18x, correct? Now let me have a look on the term containing y. So we have minus 4y here and we have minus 10y here, which will sum up to become 6y onto the left hand side. Now lastly we have to look for the constant term. So we have 8 plus 2, 10 over here, and we have 25 over here. So finally we'll have minus 15 is equal to 0. Done. Finish. So this is what the required equation of the parabola is going to be, which is x square plus y square plus 2xy minus 18x plus 6y minus 15 is equal to 0. Okay, quickly moving to the options part. Yes, option C is the absolutely correct option. So now in this question, we have a parabola whose equation is y square is equal to px. Now this parabola is passing through the point of intersection of the lines x upon 3 plus y upon 2 is equal to 1 and x upon 2 plus y upon 3 is equal to 1. Correct? So we have the equation of two lines. The first one is x upon 3 plus y upon 2 is equal to 1 and the second one is x upon 2 plus y upon 3 is equal to 1. We have to find the focus of the parabola. Before moving to the solution part, let's have a look at the options also. Okay, so these are the set of options written in front of you. Okay, now let us move to the solution part. Okay, so once again we have retained the information which was given in the question. Okay, so there was a parabola. Remember, y square is equal to px, and this parabola was passing through the point of intersection of these two lines. Okay, now the parabola is passing through the point of intersection of these two lines, so it's pretty to determine that point of intersection. How we are going to determine that point of intersection? Everyone knows, correct? Everyone knows. Yeah, we are going to solve both these equations simultaneously. Okay, so if I consider this equation, what it's written here is x upon 3 plus y upon 2 is equal to 1. If I further simplify it, what I'll get 2x plus 3y is equal to 6, correct? I'm calling this as equation. Okay, secondly we have x upon 2 plus y upon 3 is equal to 1, correct? If I simplify this equation also, what I'll get 3x plus 2y is equal to 6. I'm calling this as equation number 2. Okay, I did nothing. I just took the LCM and simplified it a bit further. Okay. Now I have to solve this equation. Okay. So for that, I'm going to make the coefficient of y equal. Here the coefficient of y is 3. In the second equation, the coefficient of y is 2. So I will multiply equation 1 by 2. I will also multiply equation 2 by 3 and I'll subtract both of them. Okay. What I am going to get? Quickly tell me. So as soon as I multiply equation 1 by 2, I'll get 4x plus 6y. Okay. And as soon as I multiply equation 2 by 3, and again I will have to subtract it also. So minus, and then in bracket I will get 9x plus 6y is equal to, onto the right I'll get 6 into 2 will become 12 and minus 6 into 3 will become 18. Correct? On further simplifying, what I'll get, see, plus 6y and minus 6y gets cancelled. That's what our motto was. Okay, 4x minus of 9x will become minus 5x and on to the right hand side I have minus 6. So this gives me x is equal to 6 upon 5. Correct? Now x is equal to 6 upon 5. This value I'm putting in equation 1. Okay, what I'll get? So 2 into 6 upon 5 plus 3y is equal to 6. Okay, this gives me the value of 3y as 6 minus 12 by 5. So further I'll get the value of 3y as 30 minus 12. Okay, what is 30 minus 12? 18 by 5. 3 and 18 will get cancelled out. Wow, the value of y is coming to be same as that of x, and it's nothing but 6 upon 5 again. Okay, so on simplifying, I got the value of x as 6 by 5. I got the value of y as 6 by 5. The parabola was passing through these points. That means this particular parabola y square is equal to px is passing through 6 by 5 comma 6 by 5. Pretty interesting. Now there is a parabola which is passing through this point, so it's obvious that this point is going to satisfy the equation of the parabola. I don't think there isn't any doubt in this, right? So I can put the value of x and the value of y as 6 by 5 in this equation. Okay, in place of y I am putting 6 by 5, in place of x I am putting 6 by 5. P is going to remain as it is. What I'll get 6 by 5 square is equal to P times 6 by 5. This 6 by 5 and one of the 6 by 5 on to the left will get cancelled out. What I'll get the value of P as 6 by 5. Okay. Now you all remember one thing, right? When the equation of the parabola used to be y square is equal to 4ax, in this kind of parabola, what was the focus? Yes, tell me quickly, what was the focus? Focus used to be at a comma 0. Correct? So that means for this parabola y square is equal to 4ax, the focus lies at a comma 0. Now carefully listen to me. We have the equation of parabola as y square is equal to px. The moment I'll compare this equation by y square is equal to 4x, the coefficient of x here is p, the coefficient of x here is 4a, that means 4a is equal to p. Correct? The value of p is already known, that means 4a is equal to 6 by 5. Obviously, now 4 and 6 will get cancelled out, so 2 2s are 4, 3 2s are 6. So finally what a will become? A will become as 3 by 10. The focus is at a comma 0. That means the focus of this parabola, the focus of y square is equal to px. Where does its focus lies? Focus. What is the spelling of focus? F-O-C-U-S. Correct. Okay. So the focus is going to lie at a comma 0. A is 3 by 10. So the focus will be at 3 by 10 comma 0. Okay. Now let us go and have a look at the options part. Yes. Option A is absolutely correct. So now in this question, we have a circle and it is given that its center lies at the vertex of the parabola x square is equal to 4y. Further, it is given that the circle is cutting the parabola at the end points of its lattice rectum. They have asked us to determine the equation of the circle. Okay. Before moving to the solution, let us have a look at the options as well. Okay. Now, moving to the solution part, we have this parabola x square is equal to 4y, right? We know that this can further be written as x square is equal to 4 into 1 into y. Exactly. So that means it's a parabola whose focus lies at 0 comma 1 and its vertex is at 0 comma 0, right? So if I draw a parabola, it will look like this. This is what the coordinates of focus is, 0 comma 1, and the coordinates of the vertex is nothing but the origin, which is 0 comma 0, right? So moving further, we have the vertex of the parabola which is at 0 comma 0. Now what we'll do next, it is given that there is a circle whose center is at the vertex of the parabola. That means the circle is also going to have origin as the center, correct? And it is given that the circle is also passing through the end points of the latus rectum. Okay, so we already know that latus rectum is nothing but a focal chord which is perpendicular to the axis of symmetry. Okay, so I am naming the end points of latus rectum as you can say M and N. So this green point on the left is M and this green point onto the right is N. Clear? Okay, now we have to determine the coordinates of the lattice rectum first. Okay, so one thing is very clear, since the y coordinate of the point S is 1, right? That means the y coordinate of the point M is also going to be 1 and the y coordinate of the point N is also going to be 1. Now we have to find the x coordinate. How can we find the x coordinate? Now if we put the value y as 1 into the equation of the parabola, because the endpoints are already lying on the parabola. So if I put y is equal to 1 here, in x square is equal to 4y, I'll get x square is equal to 4, which further gives me x is equal to plus minus 2. So that means the x coordinate of point M, the x coordinate of point M is going to be minus 2 and the x coordinate of point N is going to be 2. So we have successfully determined the endpoints of the lattice rectum, the coordinates of the endpoints of the lattice rectum, and they are nothing but minus 2 comma 1 and 2 comma 1. It was given that, once again I am repeating it, it was given that the center of the circle lies at the vertex, which is the origin, and the circle was passing through the end points of the lattice rectum. So if I try to draw a rough figure, I will be getting a circle like this. Yes, I have a very bad drawing. Pardon me for that. Okay, so I'll be getting a circle like this. The center is known. To determine the equation of a circle, two things needs to be known. One is the center and the other one is the radius. So the center is known. The radius can be known either by calculating the distance ON or by calculating the distance OM, right? Yes. Okay, because MN is acting, the latus rectum is acting as a chord. Yes. So the center of the circle is going to be, I'm assuming, sorry, the center of the circle is 0 comma 0 and its radius is going to be, so I am assuming the radius as R. So R is going to be root over, say for some time I'm calculating the distance ON. Okay, this distance I'm calculating, which is the radius, which is R here. So R is equal to 2 minus 0 whole square plus 1 minus 0 whole square. I've just used the distance formula. What I've got is root 5. Correct? So the radius of the circle is coming out to be root 5. The center is already known. So the equation of the circle is going to be x minus 0 whole square plus y minus 0 whole square is equal to root 5 square. So finally, I'll get the equation of the circle as x square plus y square is equal to 5. This is what the equation of the circle is. Okay, now if we go further and have a look at the options, yes, option A says x square plus y square is equal to 5, which is the absolutely correct option. So in this question, we just have to find the length of the lattice rectum. That's all. Lattice rectum of whom? Yes, obviously of a parabola. And the equation of this parabola is given. Okay, we just have to find what? We just have to calculate the length of the lattice rectum. Okay, let us have a look at the options also. So these are the options in front of you. Okay, we'll see which option is correct. Now moving to the solution part, I'm going to retain the equation of the parabola. Okay, I am going to do a bit of moderations in this equation. Okay, first of all, I'm going to grab this 25 and I'm going to bring it into the new denominator of the left hand side. Okay, what I'll get? I'll get x minus 2 whole square plus y minus 4 whole square is equal to 4x minus 3y plus 12 whole square upon 25. Okay. Now in place of 25, I can write root of 25 square. Anyone can write? Yes, correct. Okay. Now in the numerator also there is a square. In the denominator also there is a square. So what I can write as, I'll remove a square on both of them and I'll put a whole square. Okay, not a problem. Okay. Now in place of root 25, or you can say root, let the root be there. In place of 25, I can write 4 square plus minus 3 square. Correct? 4 square is 16, minus 3 square is 9, 16 plus 9 is 25. Okay. Now, have a look at this. Or stay for a moment. Let me take under root on both the sides of the equation. What I'll get? I'll get root over x minus 2 whole square plus y minus 4 whole square is equal to under root of 4x minus 3y plus 12 whole square will become mod 4x minus 3y plus 12 whole divided by 4 square plus minus 3 square. Am I right? Correct? Now we are in a state to carefully observe this equation. Okay? Let me take you in this way. So suppose if there is a point S having the coordinates 2 comma 4. Okay, suppose if there is a line L having the equation 4x minus 3y plus 12 is equal to 0, and suppose there is a variable point P which moves in this path. What is the distance? Sorry, there is a variable point P having the coordinate x comma y. What is the distance of P from S? Obviously, if you apply distance formula, you will get this value. Correct? What is the perpendicular distance of P from this line L? Say PM. Distance of a point from a line, apply the formula. Yes, you are going to get this value. That means whatever is written here is nothing but PS is equal to PM. Correct? So we have modified, we have reiterated the equation of the parabola in such a way that now we can conveniently know the coordinates of the focus, What is the coordinate of the focus? It's 2 comma 4. And the equation of the directrix. What is the equation of the directrix? Yes, it's 4x minus 3y plus 12 is equal to 0. Correct? Cool. So far we have the coordinate of the focus, which is 2 comma 4, and the equation of the directrix, which is 4x minus 3y plus 12 is equal to 0. Let me calculate the distance of the focus from the directrix. Let me change the color first. Let me calculate this distance. This is the distance of the focus from the directrix. Correct? How we are going to calculate this distance? Again, by using that formula, distance of a point from a line. Okay, what I'll get? Mod x1 plus by1 plus c upon root over a square plus b square. The point is 2 comma 4. The equation of the line is 4x minus 3y plus 12 is equal to 0. What I'll get? Mod of 4 into 2, correct, plus minus 3 into 4 plus 12 upon root over 4 square plus minus 3 square. I'm simplifying it here. So 4 into 2, this thing is 8. Minus 3 into 4, this thing is minus 12. This thing is already plus 12. Plus 12 and minus 12 will get cancelled out. Mod of 8 is 8. In the denominator, I have 16 plus 9, 25. Root of 25 is 5. So finally, I am getting the distance of the focus from the directrix as 8 upon 5. Correct? Everything is good to go till now? Cool. So the distance of the focus from the directrix is 8 by 5, and you all know that once the distance of the focus from the directrix is known, it's no longer a big deal to calculate the distance or to calculate the length of the lattice rectum. The length of the lattice rectum is going to be the 2 times of that distance. Correct? So the length of the lattice rectum of a parabola, of any parabola, is 2 times the distance between focus and directrix. Okay? So that means the length of the lattice rectum is going to be 2 multiplied by 8 upon 5. This will give me 16 upon 5 units. This is what the length of lattice rectum is going to be. Okay? Let us move further and have a look at the options part. Yes, option A says 16 by 5, which is correct.